to presentation mode. Okay, so I'm in Linux where things don't work as well as in Mac. Okay, so my talk is basically about just how to create domain-specific languages in Haxe using its macro system. That's kind of a thing that Haxe developers actually do a lot, and they don't always refer to their snazzy macros as DSLs, but basically in other communities it would count as that. Part of the reason I'm talking about this is because just my experience making my own DSL, my own audio DSL, some of the challenges that I faced, and then also some design considerations that you might run into if you're designing your own DSL. It could be something really simple that's just used in a few places in your application, or it could be something more elaborate that other people might use. So what is a DSL for? So if you're, I will start by not assuming that you're all familiar with the concept. Some people might go, oh, that describes a thing that I did. So you might use the concept without necessarily being familiar with the terminology. So a DSL, that's domain-specific language, is basically kind of like a programming language, but it's specialized for doing like a specific thing. It could be like a very narrow specific, or it could be a little bit broader. There's different degrees of domain specific. And then, so going over some of the advantages of creating and using DSLs. Some DSLs can be easier for non-developers to work with. So you can, for example, make a DSL designed to kind of look like a config file that like a sysadmin would understand, or you can make it kind of look like a set of procedural commands for what characters are doing for like game design or something like that. It doesn't have to be something where you're manually specifying exactly what it needs to do, like procedural native code. And then I mentioned for the second bullet point, I'll get more into the how Haxe makes DSL special, but a Hex Macro-based DSL can use metadata as input. So Hex macros can, the macro system has access to much of the Haxe standard library, and that includes like input and output. So you can actually read a JSON file and then turn that into code, or you can turn code into JSON. There's so many options, and I'll get more into that during later slides. DSLs can greatly reduce code redundancy by reducing boilerplate code. So you'll see this if you go on the Haxe cookbook and look at their macro examples. That's actually kind of a good thing to look at. Like if you're not as familiar with macros or even DSLs, after watching this, you can kind of look at that if you're not, if you want to find out more. And their examples include things where there's like kind of a lot of repetitive stuff where every time you do a thing, you're connecting to something, and with a DSL, you can kind of like avoid having to type the same thing over and over again. And then the last point is kind of another variant of the same statement, but basically with a DSL, you can get a lot done more quickly because it takes fewer lines to do more. So when you design your DSL, you can make it where one line of the DSL code translates into a lot of stuff happening under the hood. And so that this can be a wonderful way to increase productivity. You know, you're working on like a big complicated application, and there's something that you just need to do a lot of, and you can just use a DSL so that you can use a few lines just to create an interface or to create an entire class. There's so many options, especially when you do it in Haxe. Then to talk a little bit about the downside of DSLs. There are other downsides of Haxe macro systems specifically, but these are the downsides of DSLs. One is DSLs can violate the principle of least surprise by behaving too differently than the base programming language. So the principle of least surprise is basically a new developer comes into your project, or even a developer from one part of the project encounters this thing that you made, they shouldn't be surprised by what's happening, or when they make a change, it should act the same way that they're used to a change happening. But if you have a part of the code that looks kind of like the surrounding programming language, but it fundamentally behaves differently within the scope of a method or a class, then someone might do something and be like, whoa, why is this not working? And it's because it's actually a DSL in that context. And there are some ways around that in the context of Hex Macros. You can be more explicit about saying, hey, I want to use this DSL here, rather than it being implied. So those are different trade-offs that you can make. And then kind of related to that, DSLs can prevent code reuse, kind of both directions. So the language that the DSL is based on, you often can't just copy that code into your DSL code because it's processing the statements differently, and it might not be able to just let you paste in code there. So if you want to like move something from one part of the application to another, you might have to actually translate from one. It's almost like, I go to England and I need like a English to English dictionary to understand people. It's like, you think that you're going from different files in the same project that are in the same language, but suddenly you're having to translate your code that's in, say, plain Ruby into some Ruby-based DSL, for example. And then also goes the other way. You write some things in that DSL, you can't really use it in another context or another project that doesn't make use of that. So that's kind of one disadvantage of it. It's kind of the same disadvantages of mixing programming languages. Now you're having subtly different programming languages in the same project. Or even if it's on the same project, you're having one project that's a different programming language than you might think it is based on what the source files are called. Then another thing is, this is just kind of a general issue with just rolling out your own programming language, but basically like a DSL is sort of like a mini programming language, and like any small or off mainstream programming language, it might not have very good documentation, or if you're making it, you have to make sure that it's well documented. But if you're using one that someone else made, there's a good chance that not everything about it is well documented. And then the second to last point is kind of related to the first 2 points, but people will make fun of like Perl code or sometimes Ruby code as being write only, because it's very fast to make something that does a lot in a few lines. But because it does so much in a few lines, you don't know what's going on. And that's kind of the last point right here. Difficult to know what's happening when each line does so much. The advantage of being a programmer and editing and creating your own source code is you get to feel like you know what's going on. When you're using a DSL that kind of does a lot under the hood, then you're kind of left wondering what is actually going on under the hood. And sometimes you might need to sort of try to debug it. Like if there's a tool that lets you turn that DSL into the underlying code, then you might need to use that. When you're using like Visual Studio Code or whatever else with its completion and its syntax checking and stuff like that, you might also see problems, and the problems aren't clear because the problems are in like one of the lines of code that are being generated by that one line of code. So it can become very difficult to debug and a little bit confusing. It's just kind of part of the general problem with computers, where it can actually paradoxically be more confusing when the computer does more stuff for you, because you kind of don't know what it's doing for you. And then I just sort of, it's hard to see this just the way I have it formatted, but this is sort of an example of how elegant but also confusing a DSL can look. So this is the Ruby-based DSL that Chef uses. I think it's called like the recipe DSL. So it probably makes more sense to sysadmins than to actual programmers. So you can see like this first one up here, package, cpower, do, action, install. Like as a programmer, I look at that and I'm like, what is that even doing? It's just like, is this like a procedural command to install this package? It's not really clear. And if 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 you want to express ideas succinctly as a programmer, you might use pseudocode. And pseudocode can look pretty different from a DSL, ironically. Pseudocode, you would still do like, object dot method, put in the arguments. Whereas this is kind of looks a little bit almost like a YAML config file. And then, it's similarly confusing down here. There's like, data bag on it, like this right here. This is just this isn't even a method call. This is just a piece of data. So it's like, what's going on? Okay, I'm assigning a bunch of things there. Okay, that's closer to plain Ruby code. But then down here, I'm just saying template do. So probably I'm inserting into the template these variables. And that is pretty intuitive once you get the hang of it, but it just doesn't look like typical procedural code. Although that's also a general issue with Ruby. Okay, and then now let's talk about Haxe's macro system. So Haxe's macro system, obviously that's not one and the same as DSL. Not everything you would do with a macro system could really be considered, implementing or using a DSL. But a very common way to use it is to do things that are either DSLs or kind of verging on that. I think when the domain is narrow enough, people don't call it DSLs. But a lot of what you'll see is like ways to make your Haxe code look and behave the way you want it to, which to me, that sounds like a DSL. Or ways to save time by, having a few lines of code translate to more lines of Haxe that it generates. And again, to me, that sounds like a DSL. Okay, so the first point is the Haxe macro system is able to, the macros are written in Haxe. It's pretty plain Haxe code. And if you look at api.haxe.org and look at any of the classes, it always tells you like which targets it's available on. And if it includes macro on that list, then you can use that class in your macro code. So it's pretty standard Haxe code, and you're using that to modify the abstract source tree that Haxe parsed from your Haxe code. So that creates a lot of possibilities. One limitation, though, is your DSL does have to be syntactically correct Haxe code. Unless you want to have it where it reads from another file, and then in that case, you have to manually write the code to parse whatever that format is. Okay, so I already covered the second point. And then the third point is it's powerful. It's so powerful that it can actually get you in trouble. And that's one thing that I have ran into is the amount of things you can do is very tempting. And the more you do in a macro, all this is happening during compilation. So you can kind of make compilation like a very long-winded thing where it's having to run your very complicated macro code. And if there's like an infinite loop in there, then you're gonna make the Haxe compiler lockup. And you have so much access to like every little part of it. You can even access the contents of the comments. So if you want to suddenly, bring the stuff that the developer thought was not in play because it was commented out, you could even do that. So you can do some very naughty things with it. And I do some very naughty things in my DSL, and I'll talk about that later. Okay, so I have 7 more minutes. Okay, I can get. Okay, so and then second to last point, I kind of made this point before, but because you have access to some I/O capabilities and parsing and stuff like that, you can input non-code and you can output non-code. So for example, you can create a macro that lets you construct JSON in Haxe code. Now, granted, you can easily make a JSON in Haxe code, but the difference with this hypothetical macro is it would be generating it at compile time, and maybe you're saving it in the directory, or maybe you're turning it into a resource using Haxe's resource system. There's a lot of interesting possibilities there, and I kind of make use of some of them in my audio DSL. And then the last point, I personally, DSLs usually macros for me usually just work in Visual Studio Code. But I might also not have super high expectations because I'm more of a text editor person than than like a fancy IDE kind of person. I've always preferred, like, if my choices are Visual Studio, not Visual Studio Code versus Vim, I'd almost rather use Vim because it's simpler. But other people do report that sometimes the macro system messes up with their syntax highlighting and stuff like that, and their command completion. And there certainly are ways to design a macro that won't really work right in the IDE. There are definitely ways to trick the compile server, but definitely anecdotally that does seem to be an issue out there. Okay, and I talk a little bit about Hex does have some awesome DSLs. These aren't all using the macro system, at least not the way that I would envision using it. There's HXSL. So the first two are shader languages. So HXSL and heaps is that uses the Hex Macro system. When your class when you make a shader, you define a class, and then you define like a static member in that class called source, I believe, and then the HXSL macro goes through that, and then it transforms that into a shader for the appropriate target. So that's a pretty good example of actually using the Hex macro system to make a DSL. And then graphics is not a good example of that. I mean, graphics is awesome and everything, but it doesn't, as far as I can tell, that's actually just all written in C++, and that's kind of the general theme with Cause. It's almost more like a C++ library that has Haxe externs. So much of the stuff is actually implemented in C++. So I don't believe that is using the macro system. And then user Kevin Riesel, that's Kevin Leung on GitHub. He has several things that make use of macros, some really interesting stuff. There's also interesting stuff in like Haxe Tink. And there's also something that he hinted that he's working on that's like a DSL that's using the macro system. So you can kind of go through a lot of his code. He has some pretty interesting stuff. And then as I've mentioned before, there are many macros out there that we don't think of as DSLs, but they kind of are. And then there's also the, still in its early stages, but there's the HXAL that I'm working on, Haxe Audio Language. That's my DSL that I'm working on. And working on that sort of inspired me to do this talk. And then, 3 more minutes. Okay, let's briefly go over like what is the domain of the DSL. So you don't have to put like a lot of work and thought into it if it's a very narrow domain, because if you change your mind about how it works, there's only going to be a few places that they have to change. In the Haxe context, a macro can apply to like an entire class, or it can just apply to like a function. There are also ways in the compiler to invoke a macro, so you can actually make it apply more broadly if you want. So there's a lot of options there. My preferred way of doing things is I make a base class and then use auto build, and then anything that implements that base class will use that macro. And then the methods that within that class will have to conform to that DSL. So like entire applications would be like you're making something that you could actually use to write an entire application in. I don't think there are any examples of that currently, although technically with the one I'm working on, it'll be possible to make an audio plugin entirely in my DSL. But realistically, like if you're doing like a standalone application with the GUI won't be written in that DSL. That'll be just written in Haxe. I would say that mine is that both HXAL and then also like HXSL, the shader language, those will both be like the second bullet point aspect of multiple applications. And then I was going to do code tutorial, but there's not really enough time, and I think basically you can just sort of look at some examples of macros out there. I think I'd rather just take questions actually than talk more about my thing. So does anyone have any questions about this? Maybe I'll stop presenting and switch to my video. Let's see if there are any questions out there. Okay, so what is a DSL? Okay, I hope okay, it looks like I answered the question. Okay, someone is talking about, is the not XML stuff a DSL or a Haxe feature? You know, I'm not familiar with that. Let me look that up real quick. See if I can answer that question, or maybe someone else will. Not XML. That sounds like it might be kind of a DSL, though. That sounds vaguely familiar. This is that? Yeah, I think I might have found something that's not Haxe related. Yeah, okay, so let me search Haxe. Okay, so I'm trying to answer your question. I don't see not XML. Maybe because I'm using DuckDuckGo to search. Oh, I see. Oh, this is something that's used. You know, I'm actually not sure. Not XML literal. Is that referring to like a thing that's used by React and stuff like that? Okay, cool. Okay, so RL answered. It's a Haxe feature that's somewhat useful for DSLs. Okay, interesting. Okay, it's a Haxe, yeah, Haxe feature. I guess, but I think that feature is made with like React or something. Won't compile without macros. Is that true? Yeah, I think you need like a macro, but like the Haxe itself provides the not XML syntax, I believe, and then it's up to a macro to parse it. So yeah, if you want to do something, if you're familiar with React, if you want to do something like React, and support like that like inline XML, and yeah, the XML literal itself would have no default interpretation. Yes, it can kind of create like a React style interface, kind of like probably what like Coconut UI does, if anyone's familiar with that. So any other questions? Let me look around at the different question places. Okay, so nothing on Twitch, nothing else on. Okay, so it's already like 10:30. Okay, so this is the time that I think I have. Okay, yeah. I'm sorry, I'm cutting into Aiden's time. Okay, so are you ready to speak now, Aiden?
Yeah, that's fine.